In research methodology, data analysis means the process of examining, organizing, interpreting, and understanding the collected data to find useful information and draw conclusions. Simple meaning. Data analysis is the process of studying the collected facts and figures carefully to understand what they mean. Explanation in simple English. After collecting data through surveys, interviews, questionnaires, or observations, the researcher arranges the data in a proper form and analyzes it to answer the research problem or research questions. Data analysis helps the researcher understand the results clearly, identify patterns and relationships, test hypotheses, draw conclusions, make decisions or recommendations. Example: if a researcher collects students' opinions about online classes, data analysis helps to find how many students like online classes, what problems students face, whether online learning is effective or not. Short definition. Data analysis is the systematic process of organizing and interpreting collected data to obtain meaningful conclusions in research. Steps in data analysis. Research methodology context. Data analysis is an important step in research methodology. After collecting data, the researcher must organize, examine, and interpret the information carefully to get meaningful results. Data analysis helps the researcher understand the research problem and draw proper conclusions. The following are the main steps involved in data analysis. 1. Collection of data. The first step in data analysis is collecting data from different sources such as questionnaires, surveys, interviews, observation, experiments. The collected data should be relevant and accurate for the research study. Example: a researcher collects students' opinions about online learning through a questionnaire. 2. Editing of data. Editing means checking the collected data for mistakes, missing information, or incorrect answers. The researcher ensures that all questions are answered properly. There are no errors or duplicate entries. The data is complete and clear. This step improves the quality of research data. 3. Classification of data. Classification means arranging the data into different groups or categories based on similarities. Data may be classified according to age, gender, income, education, opinions. Classification makes the data simple and easy to understand. Example: students may be grouped as male and female or according to age groups. 4. Coding of data. Coding means giving numbers, symbols, or labels to responses for easy analysis. This step helps the researcher save time, organize data properly, use statistical tools easily. Example: yes equals 1. No equals 2. Coding is commonly used in questionnaire-based research. 5. Tabulation of data. Tabulation means presenting data in the form of tables, rows, and columns. It helps summarize large data, compare information easily, understand results clearly. Tables make research findings more systematic and readable. 6. Presentation of data. After tabulation, data is presented in different forms such as charts, graphs, pie diagrams, bar diagrams, percentage tables. Presentation makes the data attractive and easy to interpret. 7. Analysis and interpretation. This is the most important step in data analysis. Analysis. The researcher studies the data carefully to identify patterns, relationships, trends, differences. Interpretation. Interpretation means explaining the meaning of the analyzed data. The researcher connects the findings with the research objectives and hypothesis. Example. If most students prefer online classes, the researcher interprets that online learning is useful and convenient. 8. Drawing conclusions. After interpretation, the researcher draws final conclusions based on the findings. The conclusion should answer the research problem, support or reject the hypothesis, provide useful suggestions or recommendations. This step gives the final outcome of the research study. Conclusion. Data analysis is a systematic process of organizing, examining, and interpreting collected data to obtain meaningful conclusions. Proper data analysis increases the accuracy, reliability, and usefulness of research findings. Classification of data. Research methodology context. Classification means arranging collected data into different groups or categories based on similar characteristics. It helps the researcher organize data in a simple and systematic manner for easy understanding and analysis. Example. Grouping respondents according to age, gender, income, or education. Short note. Classification is the process of organizing data into meaningful categories to make the data simple, clear, and useful for analysis. Tabulation of data. Research methodology context. Tabulation means presenting classified data in the form of tables, rows, and columns. It helps summarize large amounts of data and makes comparison and interpretation easier. Example. Showing the number of male and female respondents in a table format. Short note. Tabulation is the systematic presentation of data in tables to make information easy to understand and analyze. Types of data analysis. Descriptive type of data analysis. Research methodology, long note in simple English. Descriptive type of data analysis is an important method used in research methodology. It is used to describe, summarize, and present the collected data in a simple and meaningful way. It helps the researcher to understand what the data shows without going into deep statistical calculations or complex testing. Meaning of descriptive data analysis. Descriptive data analysis means the process of organizing and summarizing data so that it becomes easy to understand. It focuses on describing the main features of the data such as patterns, trends, percentages, and averages. It does not explain why something happens. It only shows what the data tells us. Purpose of descriptive data analysis. The main purposes are to simplify large data into understandable form, to present data in a clear and meaningful way, to identify patterns and trends in data, to summarize information using numbers and tables, to help in making basic interpretations. Methods used in descriptive data analysis. Descriptive analysis uses simple statistical tools and techniques such as 1. Measures of central tendency. These show the central or average value of data. Mean, average. Median, middle value. Mode, most repeated value. 2. Percentages. Percentages show data in terms of 100. It helps in easy comparison. 3. Tables, tabulation. Data is arranged in rows and columns for better understanding. 4. Graphs and charts. Data is shown visually using bar charts, pie charts, line graphs. 5. Frequency distribution. It shows how many times a value or response occurs in data. Steps in descriptive data analysis. Data collection, collect data from surveys, questionnaires, interviews, etc. Data organization, arrange data in a proper order. Data summarization, use averages, percentages, and tables. Data presentation, show data using charts, graphs, and tables. Simple interpretation, explain what the data shows in simple words. Features of descriptive data analysis. It is simple and easy to understand. It summarizes large data into small form. It uses tables, charts, and graphs. It does not involve complex statistical testing. It helps in basic understanding of data. Advantages of descriptive data analysis. Easy to use and understand. Helps in quick decision making. Makes data attractive and clear. Useful for reporting research findings. Reduces complexity of large data. Limitations of descriptive data analysis. It only describes data, not explains reasons. It cannot test hypotheses deeply. It may not show relationships between variables clearly. It is less powerful than advanced statistical methods. Conclusion. Descriptive data analysis is a basic and important part of research methodology. It helps researchers to organize, summarize, and present data in a simple form. It makes large data understandable and useful for interpretation. However, it only describes the data and does not explain the reasons behind the results. Inferential type of data analysis. Research methodology, long note in simple English. Inferential type of data analysis is an important method used in research methodology. It is used to draw conclusions about a large population based on a small sample of data. It helps the researcher go beyond simple description and make predictions, generalizations, and decisions. Unlike descriptive analysis, inferential analysis not only describes the data but also explains relationships, tests hypotheses, and makes estimates about the population. Meaning of inferential data analysis. Inferential data analysis means the process of analyzing sample data and using it to make conclusions or decisions about a larger group, population. It uses statistical tools to test ideas, hypotheses, and find whether the results are meaningful or just due to chance. Purpose of inferential data analysis. The main purposes are: to draw conclusions about a population from a sample, to test research hypotheses, to study relationships between variables, to make predictions about future outcomes, to generalize research findings. Importance of inferential data analysis. Inferential analysis is very important because it saves time and cost by using samples instead of whole population. It helps in scientific decision-making. It provides reliable and valid conclusions. It supports research findings with statistical evidence. It helps in predicting future trends. Methods used in inferential data analysis. 1. Hypothesis testing. It is used to test whether a statement or assumption is true or false. Example: null hypothesis, H. No relationship between study time and marks. Alternative hypothesis, H. There is a relationship. 2. T-test. Used to compare the average values of two groups. Example: comparing marks of boys and girls. 3. Chi-square test. Used to find the relationship between two categorical variables. Example: Gender and preference for online classes. 4. Correlation analysis. Used to measure the relationship between two variables. Example: study hours and exam scores. 5. Regression analysis. Used to predict one variable based on another. Example: predicting marks based on study hours. Steps in inferential data analysis. Formulation of hypothesis, define research assumptions. Collection of sample data, collect data from selected sample. Selection of statistical tools, choose suitable tests, t-test, chi-square, etc. Analysis of data, apply statistical methods. Testing hypothesis, accept or reject hypothesis. Interpretation of results, explain findings in simple form. Generalization, apply results to the whole population. Features of inferential data analysis. Based on sampled data. Uses statistical techniques. Helps in decision making. Tests hypotheses scientifically. Makes predictions about population. Advantages of inferential data analysis. Provides deeper understanding of data. Helps in making general conclusions. Supports scientific research. Reduces cost and time. Useful for forecasting and predictions. Limitations of inferential data analysis. Requires skilled knowledge of statistics. Results depend on sample quality. Possibility of sampling errors. Can be complex to apply. Wrong interpretation may lead to incorrect conclusions. Conclusion. Inferential data analysis is a powerful method in research methodology. It helps researchers draw conclusions about a large population using sample data. It is widely used for hypothesis testing, predictions, and studying relationships between variables. Although it is more complex than descriptive analysis, it provides deeper and more meaningful research results. Qualitative type of data analysis. Research methodology, long note in simple English. Qualitative data analysis is an important type of analysis used in research methodology. It deals with non-numerical data such as words, opinions, feelings, experiences, and observations. This type of analysis helps the researcher understand human behavior, thoughts, and social situations in depth. Unlike quantitative analysis, qualitative analysis does not focus on numbers or statistics. Instead, it focuses on meaning, interpretation, and understanding of data. Meaning of qualitative data analysis. Qualitative data analysis means the process of organizing, examining, and interpreting non-numerical data to understand its meaning. It helps the researcher explain why and how something happens. The data is usually collected in the form of interviews, focus group discussions, observations, case studies, open-ended questionnaires. Purpose of qualitative data analysis. The main purposes are to understand human behavior and experiences, to study opinions, beliefs, and attitudes, to explore social problems in depth, to find meanings behind actions and events, to develop theories and ideas. Features of qualitative data analysis. Focuses on words, not numbers. Based on understanding and interpretation. Flexible and open-ended process. Used for deep study of social issues. Helps in understanding real-life situations. Methods of qualitative data analysis. Content analysis. It involves studying written or spoken material to find themes and meanings. Example: analyzing students' answers in interviews about online learning. 2. Thematic analysis. It identifies common themes or patterns in the data. Example: finding common problems faced by employees in a workplace. Narrative analysis. It focuses on stories or personal experiences shared by people. Example: studying life stories of entrepreneurs. 4. Case study analysis. It involves detailed study of a single person, group, or situation. Example: studying a particular company's success story. 5. Grounded theory. It helps in developing new theories based on collected data. Steps in qualitative data analysis. Data collection: collect data through interviews, observation, etc. Data organization: arrange data in a proper format. Data reading and understanding: read data carefully multiple times. Coding: assign labels or categories to data. Finding themes: identify patterns and key ideas. Interpretation: explain the meaning of data. Conclusion: draw meaningful findings from data. Importance of qualitative data analysis. Helps in deep understanding of research problems. Gives detailed information about human behavior. Useful in social science research. Helps in developing new ideas and theories. Provides rich and detailed data. Advantages of qualitative data analysis. Provides deep and detailed understanding. Focuses on real-life experiences. Flexible in nature. Useful for new research areas. Helps in exploring complex problems. Limitations of qualitative data analysis. Time-consuming process. Difficult to analyze large data. Depends on researchers' skill and judgment. Results may be subjective. Hard to generalize findings. Conclusion. Qualitative data analysis is an important part of research methodology. It helps researchers understand meanings, experiences, and social behavior in depth. It is widely used in social sciences, education, psychology, and management studies. Although it is time-consuming and subjective, it provides rich and meaningful insights that cannot be obtained through numerical analysis. Quantitative type of data analysis. Research methodology, long note in simple English. Quantitative data analysis is an important type of analysis used in research methodology. It deals with numerical data such as numbers, percentages, counts, measurements, and statistics. This type of analysis helps the researcher study facts in a systematic and scientific way. Quantitative analysis focuses on measurement, comparison, and statistical testing. It is widely used in business, economics, education, science, and social research. Meaning of quantitative data analysis. Quantitative data analysis means the process of collecting numerical data and analyzing it using mathematical and statistical methods to draw conclusions. It helps the researcher understand how much, how many, how often. What is the relationship between variables? Purpose of quantitative data analysis. The main purposes are: to analyze numerical data scientifically, to test hypotheses, to measure relationships between variables, to make predictions, to generalize results to a larger population, to support decision-making with facts. Features of quantitative data analysis. Based on numbers and statistics. Objective and systematic. Uses mathematical tools. Can be measured and compared. Suitable for large sample sizes. Provides clear and precise results. Methods used in quantitative data analysis. 1. Descriptive statistics. Used to summarize data in simple form. Includes mean, average, median, mode, percentages, frequency tables. 2. Inferential statistics. Used to make conclusions about a population based on a sample. Includes hypothesis testing, t-test, chi-square test, correlation, regression analysis, measures of central tendency. These show the central value of data. Mean, median, mode. 4. Measures of dispersion. These show how data is spread. Range, variance, standard deviation. Steps in quantitative data analysis. Data collection, collect numerical data through surveys, experiments, etc. Data editing, check data for errors and completeness. Coding, assign numbers to responses. Data classification, group data into categories. Tabulation, arrange data in tables. Statistical analysis, apply mathematical tools. Interpretation, explain results in simple terms. Conclusion, draw final findings. Importance of quantitative data analysis. Provides accurate and reliable results. Helps in scientific decision-making. Useful for large-scale studies. Allows comparison between groups. Supports hypothesis testing. Reduces personal bias. Advantages of quantitative data analysis. Easy to compare data. Produces precise results. Helps in generalization. Suitable for large samples. Objective and less biased. Useful for forecasting. Limitations of quantitative data analysis. Does not explain human behavior in depth. Focuses only on numbers. May ignore emotions and opinions. Requires statistical knowledge. Can be costly and time-consuming. Limited flexibility. Conclusion. Quantitative data analysis is a powerful method in research methodology. It helps researchers analyze numerical data using statistical tools and draw clear and scientific conclusions. It is widely used for testing hypotheses, making predictions, and comparing data. Although it focuses only on numbers, it provides accurate and reliable results for decision-making in research studies. Basic descriptive tools in Excel or SPSS. Mean, median, mode, standard deviation, research methodology. In research methodology, data is usually large and difficult to understand in raw form. To make it simple, researchers use basic descriptive statistical tools. Software like Microsoft Excel and SPSS, statistical package for the social sciences, helps in calculating these tools quickly and accurately. The four most important basic descriptive tools are mean, median, mode, and standard deviation, SD. 1. Mean, average. Mean is the most common measure of central tendency. It is the simple average of all values in a dataset. It is the simple average of all values in a dataset. equals sum of all values divided by number of values. In Excel/SPSS, Excel equals average, range. SPSS, descriptive statistics mean. Example: marks 10, 20, 30. Mean equals open parenthesis 10 plus 20 plus 30 close parenthesis divided by 3 is equal to 20. Use. It helps to understand the general performance or overall value of data. 2. Median. Median is the middle value in an ordered dataset. Steps. Arrange data in ascending order. Find the middle value. In Excel/SPSS, Excel equals median, range. SPSS, frequencies median. Example: data 10, 20, 30. Median equals 20. Use. It is useful when data has extreme values, outliers. 3. Mode. Mode is the value that occurs most frequently in a dataset. In Excel/SPSS, Excel equals mode.sngl, range. SPSS, frequencies mode. Example: data 10, 20, 20, 30. Mode equals 20. Use. It helps to identify the most popular or repeated value. 4. Standard deviation, SD. Standard deviation measures how data is spread or varied from the mean. In data. In Excel/SPSS, Excel equals stdev.s, range. SPSS, descriptive statistics standard deviation. Example: if SD is low, data is close to mean. If SD is high, data is widely spread. Use. It helps to understand consistency in data. Importance of these tools. Helps to summarize large data easily. Provides quick statistical results. Useful for comparison of groups. Helps in decision making. Widely used in research reports and analysis. Conclusion. Mean, median, mode, and standard deviation are the basic descriptive statistical tools used in Excel and SPSS. They help researchers to understand, summarize, and interpret data in a simple and meaningful way. These tools are very important in research methodology for both academic and professional studies. AI tools for analysis, ChatGPT, for qualitative summaries. Artificial intelligence, AI, tools are increasingly used in research methodology to support data analysis. One of the most popular AI tools is ChatGPT, which helps researchers in understanding, summarizing, and analyzing qualitative data. It is especially useful when the data is large, unstructured, and in text form. ChatGPT does not replace statistical software like SPSS or Excel, but it supports researchers by making qualitative analysis faster and easier. Meaning of AI tools in data analysis. AI tools in data analysis are computer-based systems that can process large amounts of data, understand patterns, and generate meaningful summaries or interpretations. In research methodology, AI tools like ChatGPT help in summarizing text data, finding themes and patterns, explaining concepts in simple language, supporting qualitative data analysis. What is ChatGPT? ChatGPT is an AI-based language model developed to understand and generate human-like text. In research, it is mainly used for working with qualitative data such as interview transcripts, survey responses, open-ended questions, case study notes, articles and reports, observation records. It helps researchers convert long text into simple and meaningful summaries. Use of ChatGPT in qualitative data analysis. ChatGPT is mainly used for qualitative summaries. It helps in the following ways. 1. Summarizing large text data. ChatGPT can read long answers or interview transcripts and give short summaries. Example: a long interview about student learning can be summarized into key points. 2. Identifying key themes. It helps in finding common ideas or patterns in the data. Example: from student feedback, it may identify themes like lack of time, internet issues, better understanding through online classes, simplifying complex information. ChatGPT converts difficult academic language into simple English. This helps researchers and students understand data easily. Organizing information. It can arrange data into points, categories, summaries, structured notes. 5. Supporting report writing. ChatGPT helps in writing literature reviews, research summaries, discussion sections, conclusions. Advantages of using ChatGPT in research: saves time in data analysis, helps in quick summarization of large text, easy to use and accessible, improves understanding of qualitative data, useful for drafting research reports, helps beginners in research work. Limitations of ChatGPT in data analysis. It may not always give 100% accurate interpretations. It depends on the input quality. It does not replace human judgment. It cannot perform advanced statistical tests. Results must be verified by the researcher. It may oversimplify complex data. Role of ChatGPT in research methodology. In research methodology, ChatGPT is mainly used as a support tool, not a final decision maker. The researcher still plays the main role in collecting data, analyzing data, interpreting results, drawing conclusions. ChatGPT only helps in making the process easier and faster. Ethical considerations. While using AI tools like ChatGPT, researchers must follow ethics. Do not copy blindly without understanding. Always verify information. Maintain data privacy. Use AI as an assistant, not a replacement. Ensure originality in research work. Conclusion. ChatGPT is a powerful AI tool that supports qualitative data analysis and research methodology. It helps in summarizing large text data, identifying themes, and simplifying complex information. It improves efficiency and saves time for researchers. However, it should be used carefully and always combined with human judgment to ensure accurate and reliable research outcomes. AI tools for analysis, concepts only. Monkeylearn and Orange data mining, research methodology. AI tools are modern software applications used in research methodology to analyze data quickly and effectively. They help researchers to process large amounts of data, find patterns, and generate meaningful results. Two useful AI tools for data analysis are Monkeylearn and Orange data mining. 1. Monkeylearn. Monkeylearn is an AI-based text analysis tool mainly used for analyzing qualitative data such as text, reviews, and feedback. Concept: Monkeylearn uses machine learning to understand and classify text data. Uses in research: sentiment analysis, positive, negative, neutral opinions. Text classification. Keyword extraction. Identifying themes from survey responses. Importance: it helps researchers quickly analyze large text data without manual reading. 2. Orange data mining. Orange data mining is an open-source AI and machine learning tool used for data visualization and analysis. Concept: it provides a visual platform where users can analyze data using drag-and-drop tools. Uses in research: data visualization, graphs, charts. Statistical analysis. Machine learning models. Pattern recognition in data. Importance: it is useful for both beginners and advanced researchers to understand complex data easily. Conclusion: Monkeylearn and Orange data mining are powerful AI tools used in research methodology. Monkeylearn is mainly useful for analyzing text and qualitative data, while Orange data mining is used for visualizing and analyzing structured data. Both tools help researchers save time and improve accuracy in data analysis.